my name is Sean Horgan, and this is my submission for the ICT in Education project as part of our Computing and Modern Culture module. In my tutorial, I'll be focusing on the Leap Motion Controller, and more specifically getting it working within a Unity game engine project. For anyone unfamiliar with the Leap Motion Controller, in a nutshell, it's a computer hardware sensor device that supports our hand and finger motions and maps them as input into our computer to a pair of digital or virtual hands running within an application, and in the context of this video, a pair of simulated hands in our Unity game, where we can pick up objects, throw them, and just see how our physical hand movements map to some digital hands, which is really quite accurate, and it's really cool to see, and it's really satisfying to implement in a game. So by the end of this tutorial, I aim to have the controller hooked up to my laptop or PC, and in Unity we'll have a pair of virtual hands whose movement and gestures will be mapped directly to our physical hand movements, and through that then we can pick up a simple sphere in the scene and throw it and see how we can use the packages supplied by Leap Motion to very quickly and easily implement this kind of behavior in a Unity scene. So to begin, I'll cover how to install the Leap Motion software, which includes the drivers necessary for the controller to interface with your computer, and some extra software, one for debugging in case anything goes wrong with the controller, and in the case that it's not tracking your hands properly, you can also recalibrate it within one of these applications. And there's an extra app home which acts as a central hub where you can download some really cool applications and games that people have developed for the Leap Motion controller. We'll also download the Unity game engine installer just to cover it for anybody who doesn't have it installed. Now I have both of these files already downloaded, since they're quite large files, about 400 or 500 megabytes a piece, just for the sake of saving time. And we'll also need a couple of Unity packages supplied by Leap Motion to get the controller working in Unity quite quickly. And to download these, we'll open a browser, and for Leap Motion we'll go to leapmotion.com/setup, and since I'm not using a VR headset, I'll opt for the desktop version. And since I'm running Windows 10 64-bit, I'll obviously download the Windows version, but there are options for Linux and Mac if you're running those operating systems. To download Unity, since 5.6.1, the version I'll be using for this video, isn't the latest version, we'll have to go to the Unity Download Archive, so Unity Download Archive, and navigate to the Unity 5 section, and scroll down until we see Unity 5.6.1. Since I'm running a 64-bit system, I'll download Unity Editor 64-bit. Now, to download the packages supplied by Leap Motion, we'll search for Unity Leap Motion Developer. Should be the first page that appears. And the first package we'll need is the Unity Core Assets Pack. And the Core Assets Pack provides a foundation upon which to build up your VR applications in Unity for the Leap Motion. So they include a demo scene with the hands already implemented and rigged up, so we don't have to do a lot of this dirty work. So we'll use that demonstration scene to build our scene. We'll also need the Leap Motion interaction engine, which provides all the kind of physics that come along with the hands that help us interact with objects within Unity. So I'll download the Core Assets Pack, and I'll also download the interaction engine through the module button here, and I will place both of these on my desktop just for ease of access. So that's the interaction engine and Core Assets Pack. So once we have these four pieces, that's everything we need to get up and running. So I'll begin by installing the Leap Motion controller software, and I'll briefly skip through this. It's a very simple setup, nothing out of the ordinary. So I'll return once this is done installing. The Leap Motion software is completed installing, and just to verify that, I'll press my Windows key and type in Leap, and you'll see that the Leap Motion control panel, app home, and the Orion setup executables are all available. The Orion stuff I believe is for VR headsets, so I don't think we'll be needing that. Next is to install Unity. So I'll just brush through this very quickly and skip areas where it takes a lot of time to install, but it's a very basic setup again. So you'll just accept the terms of service, and we'll keep everything standard installed to my C drive, and we'll leave that do its thing. Right, so Unity is done installing now, and it has created an icon on my desktop, so we can launch that now, and we can create a new project, and I will call this Leap Motion Unity, and it's going to be a 3D project, and I'm going to press create. Right, so Unity has created an empty project for us, and within that project is a very sparse scene, and we will populate that scene soon. And this is the scene view, and the scene view is where we'll define our level geometry and design our game. The scene, or the view below that, is the game view, and the game view is what we'll see when we play the game. So it's the view that the camera, the in-game camera here, is providing us. And the first thing we'll want to do now is import the core assets package, and that will include the hands all rigged up and a demonstration scene which we will use to build our game upon. So to do that, I will navigate over here to the Assets tab, and I'll right click and say Import Package, Custom Package, and I will select my Leap Motion Core Assets package and open. And I will say import, and that'll take a little while to import. Okay, so the Leap Motion Core Assets package is finished importing, and we can see it here in the Leap Motion folder under our Assets tab. Now, I'm not a big fan of this layout at the moment, so I'm just going to change this around. So I'm going to click here and say one column layout, and I'm just going to move it down here, and now we can make better use of our screen space, and I'll also move the game tab up next to the scene, so we have a lot more room now to work in our scene. Right, so in the Leap Motion folder you'll have a core folder, and within that we'll go to examples, and you'll see Leap Hands Demo Desktop, and this is the example scene that we want to build our game upon. So I'll double click on that, and I won't bother saving. Right, so it may appear that nothing happened, but we have actually opened the Leap Hands demo, and we can verify that up here in our hierarchy, where we can see Leap Hands Demo Desktop Scene, and within that we have one directional light which illuminates our world, and a camera which provides our game view. And if I click on camera and I then press F to focus in on it, we can see that we have a pair of hands attached to it. So with my Leap Motion controller connected to my laptop, I'm going to press play. Okay, so now we're in the game view, and if I place my hands over the controller, boop, there we go, a pair of hands, and they are tracking perfectly to my hand movements. Perfect. Right, so we know that hand tracking works. So what do we need now? Well, we're going to build up our scene a little bit. So I'm going to right click in my object hierarchy, ensuring that nothing is selected, and I'm going to say 3D object and plane. Now the plane is just a simple sheet that will act as our ground. And if we zoom in a little bit here in our hands, we'll notice that they're clipping through the plane. So I'm just going to select the camera object and using this transform widget, bring it up ever so slightly. Okay. And now we're going to add a ball into our scene. And this is the ball we'll interact with. We'll pick it up, we'll throw it, and we can move it about. So I will right click on my object hierarchy again, ensuring none of the objects are selected. I'll say 3D object and sphere, and whoa, it's a big sphere. So we're going to need to tone that down a little bit. So with the sphere selected, over in the inspector view, I will change its X, Y, and Z scale to 0.2 respectively. There we go. And just moving the sphere out a little bit, we'll see that it is a lot smaller, which is great. So now it's actually starting to look a little bit more like a ball. If I just switch to my camera object and get a preview down here, I can see that I'm quite far away. So I'm just going to bring my hands a little bit closer and just see what that looks like. Okay, so my hands can reach it. As we can see, my hands are clipping through the ball, so I know I can reach it. I'm just going to improve the view just a little bit. So I'm going to bring the hands up a tiny bit, and by pressing the E key, I'm going to switch to the rotation widget and bring it down a little bit on the X axis. And again, just a tiny bit closer. Nice, and I'll increase the field of view of the camera in the inspector view just a tiny bit, just so we can have a nicer overall perspective of what's going on. And there we go, perfect. So my hands can reach the ball. So the problem here is, you may have noticed that I can reach out for the ball, but I can't pick it up, and I can't even move it. My hands just pass through it. The reason for that is the ball has no physics applied to it, so it will not roll or move around. And secondly, it has no collision detection, so our hands hitting it would do nothing anyway. So to address that issue, I'm going to select my sphere object in the hierarchy view, or the object hierarchy, and I'm going to select add component in the inspector view. And the first thing I'm going to add is physics rigid body, and the rigid body just applies general physics to the sphere, so now it will fall and it will roll as a normal ball would. To collide with our hands, we're going to add a second component under physics once more, and I'm going to select the sphere collider, and that has added a new collider volume to our ball. And if I zoom in a little bit here, you'll see the little green lines encompassing the ball, and that is our collider volume. And because we use a sphere collider, it fits perfectly to the ball, so there's no wasted space. So if I run that once more, actually if I bring the ball up a bit and I run it, we'll see that the ball now drops to the floor. And if I reach out and try and grab it, I touch it and oh, the ball rolls away. So we have physics and we have collision working, but we can't pick it up. See, I try and grab it and it just rolls away. And that's because we have no interactions, no interaction behavior between the ball and our hands. And that's where the interaction engine comes into play. So now we're going to import the interaction engine package into Unity, the same way we did with the core assets one. So I'm going to right click down here in the project view and say import package, custom package, and interaction engine. Okay, now the interaction engine package is fully imported, and we don't notice anything immediately different in our hierarchies. So where has this engine gone to? It's actually imported into our Leap Motion folder down here, which was created when we imported the core assets folder. So everything is in a nice, tidy, neat little place. And we'll notice once we expand it, a new folder called modules. And if I expand that, I'll just close all these, we'll see the interaction engine folder. And within that then we can access the examples, plugins, prefabs, and scripts that are all needed to implement interactions between our hands and a game object. So the first thing we're going to need for interactions is the interaction manager, and that can be found under the prefabs folder in our interaction engine folder, should I say. And you'll see here the interaction manager prefab, denoted by the little blue cube. Close. Okay, so the interaction engine package has imported, but we don't notice anything immediately different in our hierarchies here. So where's it gone? Well, it's actually after importing into our Leap Motion folder that was created when we imported the core assets pack. So that's nice because everything is in one neat little place where we know we can find it. So expanding that, you'll see a new folder now called modules. And further expansion will reveal the interaction engine folder. And within that, we'll have folders for examples, plugins, prefabs, and scripts. The first thing we're going to want to implement here for interactions is the interaction manager, and that will take care of how our hands will interact with an object. It'll define the hands that we'll be using to interact with objects. So I will expand the prefabs folder, and you'll see here interaction manager, and we know this is a prefab as it is denoted by the little blue cube. So we'll drag this into our object hierarchy, and straight away you'll notice a pair of capsule looking hands will appear in our scene, and just don't worry about those. We don't need to concern ourselves with those for now. They're mostly to do with VR headsets, but we don't want to delete them or else it'll break the prefab, which could cause some problems down the line. So we'll just forget about them for now. We won't see them when we're playing, so it's okay for now. We'll see here over in the inspector view that the interaction manager has detected some rigid hands in our scene, which are not compatible with the interaction manager. So if I expand the camera and then expand our hand models, we'll see that we have a couple of rigid hands, and we don't want these at all, so we're going to delete them. So I'm going to select rigid hand left and rigid hand right and delete, and instead we're going to give our hand model interaction hands. So if I go down to my project view here and I type in interaction hand, we'll see, what's this? Interaction hand left prefab and interaction hand right prefab. So I'm going to drag the interaction hand left prefab into my hand models and the interaction hand right into my hand models, and now we have an interaction hand left and right prefab. In the inspector view, you'll note that the manager field says none. There's no interaction manager that will be utilizing these hands for interactions. So we need to reference our interaction manager here. So I'll go to interaction hand left and I'll drag this interaction manager into the manager field, and I'll do the same for the right. And you'll note that when it's highlighted in blue, it's compatible, so I can drag it in there. It's what it's looking for. So that's good to go now. Our hands are sorted, so I can minimize those again. Our interaction manager is perfect. So the last thing we have to do now is give some interaction behavior to the ball, and that will reference the interaction manager and allow our hands, our interaction hands, to pick up the ball. So to do this, I'm going to go clear that search field, and I'm going to expand the scripts folder in our interaction engine folder, and you'll see interaction behavior, C# script. You don't need to open it, you don't need to worry about the code. All we're going to do is select the sphere and drag the interaction behavior script over to the inspector view and leave go. So it is now, this script interaction behavior is now a component of our sphere. and it hasn't detected our interaction manager, so we can click autofix and boom, sorted. So now in theory we should be able to play the game and pick up the ball, since we have an interaction manager which our hands are linked to, and the ball. So let's give that a try. Okay, there's our ball, and here's my hand, and there we go. If I pinch, oops, rolled away. Let's try that again. If I reach out and I grab, the ball now stays in my hand and I can throw that away. And that's it, really. We're done. So that was a brief look into the Leap Motion controller and how we can get it working within Unity. Now what was made doesn't resemble much of a game, but you'll have to bear in mind that we did all this in the space of 20 minutes. When programming your own game from scratch without the aid of a game engine, 20 minutes isn't going to yield a whole pile, if anything. So it's a testament to how far modern technology has come to say that we can take this small and inexpensive hardware device and plug it into our computer, through which we can map our physical finger and hand gestures through the device to a pair of virtual hands, which we can use to interact with game objects in a very natural way. So you saw what we can do in the space of 20 minutes. So given a few extra days or even a week or so, you could get something really cool implemented, as you could use that time to get more familiar with Unity and its many features. So the message I'd like to get across from this tutorial, and especially tying it into the ICT and education project, is it has some real potential in the classroom. So we got a very simple scene implemented in Unity with a ball, hands that we can manipulate through the controller, physics, and interactions between our hands and the game object. 20 minutes in secondary education isn't a full class, so there's a comfortable amount of time where students can get this scene up and running very quickly, and the following weeks can be used to flesh out their game and perhaps do some extra tutorials in Unity to understand how all of its features work, so they can flesh out their game a bit more, get some really cool lighting effects and physics in, and perhaps even learn some C# scripting so they can make more specialized behaviors through code. From a teacher's point of view, teachers and educators can use the Leap Motion controller to deliver some really interactive lessons. For example, one of the many apps supplied by the Leap Motion app home is one where you can open up 3D models of internal organs. So you can look at the human heart and you can rotate it, zoom in, zoom out, point out areas of interest such as ventricles using your hands, and you can see how these areas of the heart manipulate the blood flow. And it's a really interactive way to learn about biology. And like I said, this is just but one example. There are many other ways that you can utilize this in the classroom as a teacher. So through this, you can get your students coming up and you can let them manipulate these objects with their hands, and because they're interacting with it, they're not just sitting there listening to you talking and talking and talking. They get to go up and they get to do something. And me personally, I am a very interactive learner. I like to touch things, I like to see them working, I like to get a full demonstration rather than just a theory, and that's how I take on my information. So this is a great way of delivering that same method of teaching. Considering the fact that teachers can utilize it to deliver some interactive lessons, and students can use it to develop their own VR games and hopefully spark some interest in pursuing a career or education in the games industry, the Leap Motion is a very relevant product that can be very beneficial to both teachers and students. And with that experience of developing VR games, students will already have some really useful experience that they can talk about in interviews, and it's experience that's relevant and it's now. So I'd like to just say thank you very much for taking the time to watch this video. If you followed along to get the Leap Motion working in Unity, then I hope it was of use to you and you now have a solid foundation upon which to further develop your VR game. So if you are involved in education, I hope that I have inspired some consideration to integrate the Leap Motion into the classroom, both for delivering lessons and to deliver some really constructive and relevant experience to students who could really benefit from it should they decide to pursue an education in the games industry. So once again, I'd just like to say thank you, and I hope you enjoyed. My name has been Sean Horgan, and this has been my submission for the ICT and Education project.